So here's an explanation of the answer key from the Chapter 7 review. Number 1, asks you to simplify the square root of 180. So what you're going to do here is make your factor tree. I know that 180 is 18 times 10. 18 is 9 times 2. 9 is 3 times 3. 10 is 5 times 2. So what I'm going to do now is highlight my primes. All of these are primes. So that means that a square root of 180 is the same thing as the square root of 2 times 2 times 3 times 3 times 5, which we get from these primes down here. Now, because I'm taking the square root, I'm going to look for groups of 2. There's 2 2's, there's 2 3's. 2 times 2 is 4, and the square root of 4 is 2, so I'm going to bring a 2 out, and these are no longer inside. 3 times 3 is 9, and I know the square root of 9 is 3, so I'm going to bring a 3 out, and these are no longer inside. So outside I have 2 times 3, which is 6, and underneath the radical I still have this 5. So 6 square root 5 is your final answer. Number 2 is the same idea. It's saying 3 square root 8. So I'm going to factor tree my square root 8. Makes it 4 times 2 and 2 times 2. Here are my primes down here. So again, same concept. We know that 3 square root 8 is the same thing as 3 square root 2 times 2 times 2. Since I'm taking the square root, I'm looking for groups of 2. So here's a group of 2 2's. I know 2 times 2 is 4, and the square root of 4 is 2. So out comes a 2, and these go away. Now because I already have a 3 outside, this becomes 3 times 2, which is 6. And my other 2 is left underneath the radical. And so there's your final answer there. Question number 3. Number 3 says quadrilateral ABCD is a trapezoid. So let me just redraw it here real quick. A, B, C, D. AD is 15 inches, so there's 15 inches. AB is 50 inches, and BC is 20 inches. The altitude is 12 inches, so they drew this line in here, put a right angle, and they said that's your altitude, that's 12 inches. What is the area of the trapezoid? Well, first thing you have to think about is, what's the area formula for a trapezoid? Well, it's 1/2 times the height, or the altitude, times base 1 plus base 2. Well, I already know some of this information, but not all of it. I know my height is the same as my altitude, so that's 12. I know base 1 is 50, and base 2 I don't know, but I do know that it's the length of CD. So what we can do here is we're going to use our brain power. We're going to figure out the length of CD. And if I drop a line in here, I know that that measures 12 because it's the same as the altitude. And so I have a right triangle. I know this is 12, the hypotenuse is 15, and I can solve for this small part on the bottom. I also know that I can do the same thing on the right side. Here my hypotenuse is 20, this is 12, and I can solve for this little part here. I know that 50 is the middle part, just from here to here. And so what I'm going to do is I'm going to solve for this part, and I'm going to solve for this part, and I'm going to add it to the 50. So let's work that out. So we'll have 12 squared plus, I'm going to call this x. X squared equals 15 squared. And that gives me, when I'm finished squaring and subtracting, I get x squared equals 81. So x equals 9 or negative 9, but we know it can't be negative 9 because you can't have a negative length of a trapezoid. On the other side, we'll have 12 squared plus, let me call this y, plus y squared equals 20 squared. And And same thing, I'm going to square and subtract. I end up getting 256. When I square root both sides, I get that y is 16 and negative 16. But I know I can't use the negative 16 because we're talking about lengths of trapezoids, or sides of the trapezoid, so I get y equals positive 16. That means my base 2 is 9 plus 50 plus 16, which is 75. So now I'm just going to substitute in 1/2 times 12 times base 1 was 50 plus, now we know this whole base 2 here, this whole thing, is 9 plus 50 plus 16, which is 75. And we work that out, and you get 750 inches squared. Final answer. And remember, the area is always measured in units squared. Number 4. Number 4 gives you this triangle here. It tells you this is a right angle, A, B, C. And it tells you that this is x minus 1 and this is x minus 3. And it wants an expression for AB, which is the hypotenuse here. Well, I know that if it's a right triangle, I can use Pythagorean's theorem. So I can say x minus 3 squared, notice I put parentheses to show the whole quantities being squared, plus x minus 1 squared equals AB squared. And now it's just a matter of working this out. So x minus 3 times x minus 3, because remember, that's what it means to square something. You can't just distribute the 2 inside because of this minus sign. X minus 1 times x minus 1 equals AB squared. So we get x squared minus 3x plus 9. And that comes from double distributing here. And then in the second part, we get plus x squared minus x plus 1. And that comes from double distributing here. Equals AB squared. I'm going to combine all my like terms. So I get 2x squared minus 8x plus 10 equals AB squared. Now how do we get rid of the square? Well, we square root. So I get that AB, because these cancel, equals the square root of 2x squared minus 8x plus 10. Final answer. Moving on, number 5. Let's see, what's number 5 saying? Okay, the endpoints of one leg of a right triangle are 2, 4, and negative 3, 6. Which of the following points could be the third vertex of the triangle? Okay. So 1, 2, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6. So these are, let's see, these are my points. And it says this is a leg of the triangle, not the hypotenuse. So my options for my answers are A, negative 3, 4, B, 2, 6, C, 0, negative 1, and D, 1, 1. So let's start out, I'm going to use red here. So negative 3, 4, 1, 2, 3, 4. So I'll be right here. We'll do this one in green. 2, 6, I'd be here. 0, negative 1 is here. And on my left one will be black. And 1, 1 is here. Now, I'm going to start out with A. Well, if I connect these, it is true that negative 3, 4 will make a right triangle. Okay, it's on the same level has the same x value as this point, or the same y value as this point, the same x value as this point. That makes a right angle. However, in the problem, it said that this black line is a leg, and here it's a hypotenuse. So automatically A can't work, because we want this black line to be a leg and not a hypotenuse. So A doesn't work. So let me erase this stuff. All right, now the same thing happens with B. If we look at this green point, if I make a triangle here, it's going to make a right triangle, but this black line's the hypotenuse, and we want it to be the leg. So B can't work either. Now let's look at C. So here's C. Well, this looks like a right angle here, but we have to double check to make sure it actually is a right angle. So what I'm going to do is I'm going to find the lengths of all three sides. I'm going to do the Pythagorean theorem to make sure that they're actually, that a squared plus b squared actually equals c squared. So here, I'm going to say this is the square root of, and we'll have, let's see, which point is which? This is negative 3 comma 6, and this is 2 comma 4. So I'm going to say 6 minus 4 squared plus negative 3 minus 2 squared, and that's the square root of 6 minus 4 is 2, and negative 3 minus 2 is negative 5. So that gives us that this is square root of 4 plus 25, which is square root 29. So that's the length of this leg. Now my other leg over here, so there's one. My leg over here is going to use this point and this 0, negative 1. So I'm going to say 4 minus negative 1 squared, 4 minus negative 1 squared, plus 2 minus 0 squared. So that gives us 4 minus negative 1 is 5. So 5 squared plus 2 squared. So we're going to end up with the same thing, 25 plus 4, square root 29. So this leg also measures square root 29. Now the hypotenuse over here, we're going to use, let's see, distance formula, square root of 6 minus negative 1 squared plus negative 3 minus 0 squared. So we get square root of 6 minus negative 1 is 7 plus negative 3 squared. So we get 49 plus 9, which is square root 58. Now we need to check to make sure this actually works with the Pythagorean theorem. So I'm going to come over here. I know this would be my hypotenuse, the longest leg. So I'm going to check square root of 29 squared plus square root of 29 squared equals square root of 58 squared. Remember, squared and the square root cancel, so we get 29 plus 29 equals 58, and that is true. Check. It works. So this is a right triangle. I'm not even going to check D because I already know that this works. And so C is my final answer. Okay, this point has to be the third vertex. Well, this works as the third vertex to make this a right triangle. Okay, number 6. Number 6 says find the perimeter of triangle ABC. So here's triangle ABC. And they tell us that this whole thing is 20. And that this is 12. Alright, so I know that to find the perimeter of triangle ABC, here's triangle ABC, I need to know the length from A to B, from B to C, and from A to C, because that's how we find perimeter. We add up the lengths of all the sides. So I'm going to start out with a Pythagorean theorem to find length of AC. So we'll say 12 squared plus AC squared equals 20 squared. Let me flip to my notes here. We've got 144, 400. When you subtract, we get AC squared equals 256. We square root, and so AC equals 16 or negative 16, because that's what happens when you take the square root. We can't use the negative value, so we get positive 16. So here, that's 16. Now I'm going to use my geometric mean to figure out AB and BC. So I'm going to start with AB. And let me call that X here. Okay. So 16 is a leg. Remember that our proportions go that the leg is the geometric mean of the small part of the hypotenuse and the whole. And the altitude, if we were going to do an altitude, the altitude is the geometric mean of the small part of the hypotenuse and the small part of the hypotenuse. So in this case, I'm going to say 16 is my leg. The small part of the hypotenuse that corresponds with it is x, and the whole hypotenuse is 20. So I'm going to cross multiply, and that gives me 20x equals 256. And so divide, I get x equals 12.8. So this is 12.8. Now I could set up another ratio to solve for BD, but I'm just going to subtract. 20 minus 12.8 is 7.2. So I know this is 7.2. And now I can set up a ratio to figure out BC. So I'm going to call this y here. The y would be my altitude. So I'm going to say y is the geometric mean of the small part of the hypotenuse and the other small part of the hypotenuse. So we'll cross multiply, and we get y squared equals 92.16. We square root, and remember, square root, you get a positive and a negative. However, we don't want the negative value because we're talking about the lengths of the sides of a triangle. So this is positive 9.6. So finally, our perimeter is 16 plus 12.8 plus 9.6. And so perimeter is 38.4 units. Done. And I'm going to stop here, and I'm going to start a new video for the second part.